Well, hello friends. I'm going to do a short walkthrough of a project named Spegel. Spegel, or mirror in Swedish, is a stateless cluster local OCI registry mirror. And what it enables is that nodes in a Kubernetes cluster can pull container images from other nodes that already have these images. It's created by my colleague Philip Lane, and a couple of use cases is that locally cache images from external registries with no explicit configuration, avoid cluster failure during external registry downtime, improve image pull speed and pod startup time by pulling images from the local cache first, avoid rate limiting when pulling images from external registries like Docker Hub, decrease egress traffic outside of the cluster network, and increase image pull efficiency in edge node deployments. We've ourselves seen issues in Kubernetes scaling or auto-scaling nodes when things like GitHub container registry is down. In this case, and that's the main case from Philip to create this project. The prerequisites is that you need to update the containerd configuration, and as far as I know, in Azure Kubernetes Service or AKS, it's verified to be working, and EKS from Amazon. And what we do is, or what Spiegel does, is that it updates the mirror configuration on the nodes and makes sure that all the nodes participate in a distributed hash table. I can't go into details how that actually works, but it's kind of like what BitTorrent is using. In this case, we can see an example where we have one node with a containerd, and containerd pulls from I think it's a host port or a node port, and it goes to its local Spegel instance, and that Spegel instance can forward it to another node that actually has that container image. It's also possible to go to a load balanced service and do the same, and I think that's the case for when you haven't been able to pull Spegel yourself if that image registry was down. And as a fallback, it can always go back to the registry if Spegel fails or you can't locate that specific image in the cluster. There are some alternatives for this: Harbor, SOT, Dragonfly, and Kraken. My understanding is that Kraken isn't that heavily maintained, and Dragonfly requires both Redis and MySQL, and Harbor and SOT are bigger, but I haven't used them myself, so I can't really speak for that. And the installation is just a simple Helm chart, and as long as you have this specific configuration for containerd, it should work for you. I've prepared Azure Kubernetes Service cluster. We have 3 nodes in this cluster. Let's check it out. So we have 3 nodes here running. I don't think I just created it. And we just have stuff running in Calico, Tegra, and Kube system. So we don't have anything specific running here. But before we go into the details of actually setting it up, I was thinking that we just should do a short walkthrough of like the main function and see what it actually does, or at least take a short look at it so we can have a better understanding of what it does. Philip is using the GoArg library that makes it quite easy to take arguments and environment variables as parameters, as well as set the defaults. We have the registries and mirror registries, I think, and it just takes URLs. We have image filter, registry address, router address, metrics address, some configuration for the containerd socket, namespace, config path, containerd, mirror, add and remove. I think this makes it possible to enable and disable if we want to add the actual containerd configuration for the mirrors. We also have the kube config path and leader election namespace and leader election name. In the main function, we create the args and parse them. Then we create a logger, and in this case we're using SAP, and then we're using Zapper. I think that's part of the logger library. And when we have that logger, we pass it to the run function together with the arguments. If the run function returns an error, we just print it and then exit 1. Otherwise, we just say gracefully shut down. In the run function, it seems like we're creating a Kubernetes client set. So we have a Kubernetes client here. We pass it the kube config path. Then we have the containerd client. We pass it the containerd socket with the namespace, and we defer closing it. Then we create a new context with the logger library, and we pass it the logger. Then we also create a notify context where we pass the previous context, and we say that that context should be cancelled when we receive the signal sig term. And then we create an error group with this context. After this, we create a file system, and then we pass this file system to add mirror configuration and remove mirror configuration. And this is just to update the actual node's configuration with these mirrors. After that, we create a mux and to handle the metrics. And in this case, we're using the Prometheus Golang client. And we're passing it the metrics address. Then we use the error group, and we start the metrics listener, and then we wait for the context to be done, and after that we create a shutdown context and shut down the metrics server. After that we create a bootstrapper. I'm actually not sure what this does, but my best guess is that the bootstrapper handles like something with how the different Spegel instances find each other and how they start up and things like that. Then we create the peer-to-peer router, and we wait for the context to be done, and if it's done we close the router. And then we also start tracking and this tracking most likely has to do with what containers this instance or this node has. After that, we create a new registry. We pass it the registry address, and then we launch it. And then we also wait for it to shut down. And then we wait for anything or all the error group instances to return. And if any of them return an error, we will return the error and exit one. And if you haven't used error groups before, if one of them return an error, it will cancel the context, and that will cause all others to cancel as well. So this is like the main part of the code. As always, Philip does a great job of having quite a readable structure in the code he creates. I'm not going to dig much deeper. Perhaps we should take a look at the new registry and see what it does. Some gin configuration, how to handle logging, registry handle. We do the health check, and then any requests to params should be passed to the registry handler, which is this one, registry handler. And this is just a gin handler. If the method is get, or if it's not get or head, we return status not found. We do a path clean to just check the URL path for the request, checks that it's v2. If its method isn't get, we return status not found. Oh yeah. So if you do head, you should reach this one, and if you just do a get to this path, then we should return status OK. After that, we have always expect remote registry header to be passed in request remote registry. And we have a header. Let's not go too deep, but if we don't get the remote registry, we return an error. If it's a mirror request, we do something special for the mirrors, and then we take a look at the reference, and if that's okay, we handle the manifest, and then we if it's not a manifest, let's see here, okay, then it's a blob, and we handle that. And if nothing matches, return 404. Alright. I think that should be enough. Perhaps we should take a look at the end-to-end test as well. I think the end-to-end test is written in the make file. So the make, this is run during the pull requests, validation, etc. So the end-to-end test creates a temporary directory. It exports the kind. Kind is Kubernetes in Docker. So the kind kubeconfig to the new temp dir kind.kubeconfig. And then it just prints the kubeconfig path. After that, it creates a kind cluster based on the kind config. Let's take a short look at the kind config. The kind config just patches the container D config patches, and it removes the mirrors. And when it has removed the mirrors, container D config patches, and it just adds the required config. And then it creates one node that's a control plane, then 3 workers where 2 of them have the labels test. after that, it executes on a specific node, kind node, the worker, the first one, and it's using the container D, like CLI in the container D namespace k8s.io. It pulls the image for Nginx with a tag, a SHA, and a tag with a SHA. And after that, it removes the default route on each of the nodes. So that's the control plane and the 3 workers. And this enforces that we don't have any access to the internet, so we shouldn't be able to pull the image on any of these nodes. So we know that we have pulled the image on for Nginx on one of the nodes, and then we delete the default route. After that, we load a Docker image, and referencing the current Spegel image that's built. Then we run kubectl create namespace for Spegel. After that, we run Helm, and we install into the namespace Spegel the short Spegel. And we set the image pull policy to never, and the image tag to the tag we have recently built. And after that, we just wait for the status of the Spiegel demo set to be successful. We will wait for 60 seconds, and after that we apply the end-to-end test Nginx configuration, and that's just creating a namespace for Nginx, and we just create one for the tag, one for the SHA, and one with the tag digest, and one for the tag and digest. And then we wait for these 3 to have the condition available, and then we delete the cluster. Alright, so let's take a look at how we install this. We run Helm upgrade, we create the namespace, we specify the namespace, and then we specify the version. Let's check that this is the latest version. This is 004, yeah. And then we specify the Helm chart, which is in the GitHub container registry. Alright, let's try that. So we don't see anything in the default namespace, and we see 3 Spiegel instances. And we can see them start up and establishing connection with the bootstrap node. So that we have 3 instances, and it seems like the first 2 at least is working. Leader is self-skipping connection. Yeah. So I think all of them are working. And now we should be able to do something like we list the nodes. So we take the first node, and I've prepared a manifest here. So we just deploy Nginx to the first one. And if we do that, apply, so we should see it being created on the first node. Seems to be working all right. And if we look at the different logs, we should be able to see that a mirror doesn't find that specific manifest or blob. And if we check the other ones, we should see the same thing here, that it's not able to find it because it was the first node pulling it. And just to verify, perhaps we should look at this one as well. Yeah, everyone is returning 404. So let's delete it. And let's change the node to another one. We can see it's up and running. It went really fast. And let's look at the logs again. So now we can see 200 here. So we're hitting it. So that seems nice. We can see 200 here as well. And let's just take a look at the last one. And 200 here. So we're able to pull it and it seems to be working. And it's, at least it felt like it went a lot faster than before. All right, so that's about it. We have Spegel, that's an open source project to solve issues we've been seeing with the Kubernetes clusters, where we can't scale nodes if the container registry nodes, specific images for the nodes are located, and Spegel solves that problem. It has a really small memory footprint and doesn't require any kind of persistence. So it's quite easy to set up, and it's been working quite well for us. And of course we need to mention that from when Philip created it until now, let's say that's about a month, he has received 132 stars here on GitHub. I think the second best project is about half of that, and that project has been live for perhaps 2 years, so we're quite happy about this as well. It's a nice project solving a specific issue in a nice way, and if you like cool technology, take a look at the code, because how a distributed hash table is used to actually distribute what node has what image and stuff like that is really awesome. Well, that's it for today. Have a great day, and thank you for watching. Bye.